Definition: a trapezoid is a quadrilateral with exactly two parallel sides. Figure 4.32 shows trapezoid HJKL, in which segment HL is parallel to segment JK. The parallel sides, segment HL and segment JK, are bases, and the non-parallel sides, segment HJ and segment LK, are legs. Because angle J and angle K both have segment JK for a side, they are a pair of base angles of the trapezoid. Angle H and angle L are also a pair of base angles because segment HL is a base. When the midpoints of the two legs of a trapezoid are joined, the resulting line segment is known as the median of the trapezoid. Given that point M and N are the midpoints of the legs, segment HJ and segment LK, in trapezoid HJKL, segment MN is the median of the trapezoid. See figure 4.33a. If the two legs of a trapezoid are congruent, the trapezoid is known as an isosceles trapezoid. In figure 4.33b, RSTV is an isosceles trapezoid because segment RV is congruent to segment ST, and segment RS is parallel to segment VT. Every trapezoid contains two pairs of consecutive interior angles that are supplementary. Each of these pairs of angles is formed when parallel lines are cut by a transversal. In figure 4.33c, angles H and J are supplementary, as are angles L and K. In figure 4.32, suppose that measure of angle H equals 107 degrees and the measure of angle K equals 58 degrees. Find the measure of angle J and the measure of angle L. Solution: because segment HL is parallel to segment JK, angles H and J are supplementary angles, since segment HJ is a transversal, as are angles L and K, transversal segment LK. Then, measure of angle H plus the measure of angle J equals 180 degrees, and measure of angle L plus the measure of angle K equals 180 degrees. Substitution leads to 107 degrees plus the measure of angle J equals 180 degrees, and the measure of angle L plus 58 degrees equals 180 degrees. So measure of angle J equals 73 degrees, and the measure of angle L equals 122 degrees. Definition: an altitude of a trapezoid is a line segment from one vertex of one base of the trapezoid perpendicular to the opposite base, or to an extension of that base. In figure 4.34, segments HX, LY, JP, and KQ are altitudes of trapezoid HJKL. The length of any altitude of HJKL is called the height of the trapezoid. The preceding activity may provide insight for a number of theorems involving the trapezoid. Theorem 4.4.1. The base angles of an isosceles trapezoid are congruent. The following statement is a corollary of Theorem 4.4.1. Corollary 4.4.2. The diagonals of an isosceles trapezoid are congruent. Theorem 4.4.3. The length of the median of a trapezoid equals 1/2 of the sum of the lengths of the two bases. Theorem 4.4.4. The median of a trapezoid is parallel to each base. Theorems 4.4.5 and 4.4.6 enable us to show that a quadrilateral with certain characteristics is an isosceles trapezoid. Theorem 4.4.5. If two base angles of a trapezoid are congruent, the trapezoid is an isosceles trapezoid. Theorem 4.4.6. If the diagonals of a trapezoid are congruent, the trapezoid is an isosceles trapezoid. Theorem 4.4.7. If three or more parallel lines intercept congruent line segments on one transversal, then they intercept congruent line segments on any transversal.